Hello students, today we will study about the geometrical meaning of zero of a polynomial. This is a topic of standard 10 chapter number 2 polynomials. Okay, so in last class we have studied that there are basically three types of polynomial that we have to study in standard 10: linear polynomial, quadratic polynomial and cubic polynomial. So first type is of linear polynomials. So standard form is p of x is equals to ax plus b. As we know that by changing the value of x, this value is also changed. So we can take this as another variable. Let's take it y. So y is equals to ax plus b. Okay. So why we take y? Because by taking y, now we can represent this value or this expression on the graph. That is why we take it as y. Okay. So suppose there is an example of linear polynomial p of x is equals to 3x plus 2. So by taking p of x is equals to y, we will get y is equals to 3x plus 2. Now to take the points, we will take different value of x, and according to that we will get the value of y. So by taking x is equals to 0, we will get y is equals to 2. By taking y is equals to 0, we will get x is equals to minus 2 upon 3. This you know very well how to find out. Okay, you can get another points also, right? Okay, so by plotting this on the graph, the first point is 0, 2. So the 0, 2 is this point, and the second one is minus 2 upon 3, 0. So minus 2 upon 3 is approximately near to the minus 1. So let's take it here. So by joining this point and this point, we will get a line, and that is the line of 3x plus 2 polynomial, right? As we know that the degree of polynomial is 1 and it is a linear polynomial, its graph is also a straight line. Okay, so we have to notice one thing here is that this graph of y is equals to 3x plus 2 polynomial intersect the x-axis in one point. Okay, so it has a relation to its number of polynomials. Okay, as it touches the x-axis in only one point, it is, we can say that this polynomial has only one zero. Okay, so let's find out the zero. So to find out the zero of p of x is equals to 3x plus 2, we will get p of x is equals to 0. So 3x plus 2 is equals to 0 and x is equals to minus 3 upon 2. Here we get only 1 0, right? As I have said that this graph is touches the x-axis in one point only, we can get 1 0 only. Okay, so this thing and this thing is matched to one another. Okay, that you have to understand. Okay, so is it possible that this graph do not touch the x-axis in any point? Yes, it is possible. Suppose that there is an equation, there is a polynomial f of x is equals to 3. Now this is a constant polynomial. So by taking this y is equals to 3, so the graph of y is equals to 3 is like this: 1, 2 and 3. So this graph will pass from this 3 value, okay, and it is parallel to the x-axis and it is not touching any point to the x-axis. That is why the zero of this polynomial is also 0. We cannot get any value such that this polynomial becomes 0. Okay, so this is the graphical geometrical meaning of the zero of linear polynomials. Okay, so let's see about the quadratic polynomial. So the standard form of the quadratic polynomial is ax square plus bx plus c. So let's take an example. P of x is equals to x square minus 3x minus 4. Okay, So by taking this is equals to y is equals to x square minus 3x minus 4. By taking the different value of x, we get the different value of y. Okay. So by taking 0, we will get minus 4, minus 1, 0. By taking 4 also, we get the 0. Yes, here for two value of x, the y is same. Okay. This you can verify by putting this value in this equation. Okay. So this kind of points we can get from this polynomial. Right. Now we will plot these values. Okay. So 0, 4 point is 0, minus 4, minus 1, 0 is here. Sorry, minus 1, 0 is here. Yes, this is 0, minus 1, 0. This is different. Minus 1 and 0. Okay. Third one is 4, 0. 4, 0 is here. Minus 2, 6. Minus 2, 6 is here. 2 minus 6 is here. And 5, 6 is here. So by joining all this type of points, we will get this type of shape. And this type of shape is called the parabola. Okay. So for quadratic polynomial, we will get this kind of graph. Okay. Now see, this graph touches the x-axis in 2 points. Here it touches it minus 1, 0, and here it touches the x-axis at 4. So we can say that this polynomial has 2, 0. Okay. Let's verify it by finding the 0. So to find out the 0, we will get p of x is equals to 0, x square minus 3x minus 4 is equals to 0. By splitting the middle term, we will get x square minus 4x plus x minus 4. By taking x as common from this 2, we will get x minus 4, and by taking 1 as common, we will get x minus 4. So x minus 4 is common. So in another bracket, we will get x plus 1 is equals to 0. So by comparing this with 0, x minus 4 is equals to 0. So we will get x is equals to 4. And again comparing this to the 0, we will get x plus 1 is equals to 0 and x is equals to minus 1. So we will get how many zeros? 2. Why? Because the maximum power is 2. So maximum 0 is 2. And from the graph also, we can say that as it touches the x-axis in 2 points only, this polynomial has maximum 2 zeros. Okay. So these both values we can get here also, 4 and minus 1. Okay. So this same type we will see about the cubic polynomial. Okay. So let's see the cubic polynomial. So standard form of this cubic polynomial is p of x is equals to ax cube plus bx square plus cx plus b. Okay. So one of the example is x cube minus 4x. So by taking this as y, same way we have done in quadratic polynomial, we will get the different value of x and y. So these are the values. You know very well how to find out these values. Okay. So by plotting this point, we will get minus 2, 0. Minus 2, 0 is here. Minus 1, 3. Minus 1, 3 is here. 0, 0 is the origin. 1 minus 3. 1 minus 3 is here. And 2, 0 is here. So by joining all this point, we will get this type of shape. Okay. So this type of shape we will get in cubic polynomial. Okay. So as we know, we can see here that this graph touches the x-axis in 3 different points, first, second and third. So now we can say that this polynomial has maximum 3 zeros. Okay. So zeros, f of x, to find the zeros, we get f of x is equals to 0, x cube minus 4x is equals to 0, x is common, so we will get x square minus 4 is equals to 0. To factorize this, we will use the identity. So x square minus 4 we can write down as x minus 2 and x plus 2. So by comparing these three with 0, we will get first x is equals to 0, second x minus 2 is equals to 0. So it is x is equals to 2. And by comparing this x plus 2 is equals to 0, we get x is equals to minus 2. So these are the 3 points or 3 zeros we get for this polynomial, and it is also we can see in the graph of these polynomials. Okay, so this is the all about the graphical representation of zero of a polynomial or geometrical meaning of the zero of a polynomial. Okay, so now you can decide by just seeing the graph of any polynomial that how much zero it has. If the graph of the polynomial touches the x-axis in 1 point, it has only 1 0. If it touches the x-axis in 2 point, it has 2 0. If it touches the x-axis in 3 point, it has 3 0. If it touches in 4 point, it has 4 0. And if the graph does not touches the x-axis, then it has not any zero. Okay, so this is all about this lecture. Okay, thank you.